over the whole last question, that saturated solution of calcium hydroxide. Okay, so let's take a quick look at that so that you all know what the heck you are doing for that. So we have a saturated solution of calcium hydroxide, CaOH2. And what I would like you to do is I would like you to talk with your neighbors about what it means for a solution to be saturated. Okay, saturated. It means that there is what? Yes. Yeah, it contains the maximum amount of dissolved solutes. Who is the solute in our mixture? Calcium hydroxide. Who is the solvent in our mixture? Water. Okay, so when we then go to draw our picture of our saturated solution, okay. Oh, before we do that, I want to know, how do we know that the solution, how did we know that we had a saturated solution? How did we know we had reached the maximum amount? How did we know our solution was saturated? Yes, because you can see through it. That's an indication that it's dissolved. Does that tell us that we have the maximum amount dissolved? Maybe not. Yes, because you can have a solution, like let's say I took a little bit of salt and I sprinkled it into a glass of water and I stirred it around. It would be see-through. I would have a solution, but it would not be a saturated solution because I could continue to add more salt and I could stir it and it would still dissolve. Cade? It's what? There's powder at the bottom. What does that tell you? Yes. Not everything can be dissolved. Yes. So we know it was saturated because even though we heated it and stirred it, both things which will make more dissolve if it's dissolvable, some of the solid remained undissolved. So in our saturated solution, we're going to draw a beaker. And today we're not going to draw little mini crystal lattices. Today we are just going to draw one big crystal lattice to simplify things, okay? Because if we do a whole bunch of little ones, it just gets really messy. So today we're going to simplify and just draw one crystal lattice. Okay, so we've got that there. What substance is this? That is the calcium hydroxide, yes. And what state is it there? It is a solid, okay? Now, if this was a perfect world, we would use an entire sheet of paper and we would have lots of these little mini things all over our page, but we want to be able to fit it in a small area, so we're just going to draw one of those crystal lattices. What else is in the beaker? Yes, H2O. But our diagram is going to get way too complicated if we draw Mickey Mouse, Mickey Mouse, Mickey Mouse, Mickey Mouse everywhere, yes? And in fact, it will still be too complicated even if we simplify our water down to, you know, just a little particle that looks like that. It would still just, it would be a sea of red, yes? Because this entire thing is made of water molecules. There are too many to draw. If you want to draw a few, feel free. You can be like, okay, I'm going to draw some of the water. But just understand that there's not like random water molecules just floating around. The entire thing would be coated in water molecules. What else is in the beaker? Yeah, the dissolved CaOH2. Now, do you remember what happens when we dissolve? The ions all come apart individually, okay? So we're going to have individual calcium ions, Ca2+, and we will have individual hydroxide ions, OH-, OH-, floating around in our solution. So those are individual free-floating Ca2+ ions. What state should we put in our little brackets at the bottom of Ca2+? That is aqueous, yes. okay? AQ stands for, in case you don't know, you don't need to write it down obviously if you do know, aqueous, which means dissolved in water. So that's good. We also have OH minus aqueous. So in our saturated solution, we have both dissolved free-floating ions So we have both the dissolved individual ions and some undissolved solid. We can write a chemical equation that shows the dissolving process. But I'll wait a minute for you guys to be done writing what you're writing now. So we can take CaOH2, solid, and it will dissociate in water, or at least some of it will dissociate in water. And if you think about the word associate, if I associate someone with someone, I get together with them and interact with them, yes? If you have an association, it's a group of people who get together. So if you dissociate, you're not getting together, you're coming apart, okay? So to dissociate means to separate. So the CaOH2 solid, which is together as a crystal lattice, separates in solution into Ca2+, which is aqueous. Yes. I'm going to come closer to that. You could if you wanted to, you don't have to. Yeah? The heat definitely helps because it was more soluble. If you have sulfur that was soluble, so it's the water that dissolves it, the heat helps the process. Basically what happens often with the heat is that it expands the space between the water molecules just a little tiny bit, which allows them to accommodate more solidity. Okay. It's like a little askew. Tell me when that happens. Fix that. So our other ion that we get, of course, is the hydroxide ion. And it is also aqueous. Yes, yes. Can you think of a way of making that reaction, the way it is written, better? Can you make that reaction better? Sorry? Did you say something? 2OH. Yes. Right now it is unbalanced. We have a 2 here. Yes. So we have 2 hydroxides. So over here we can put a 2. Okay? Because for every 1 calcium you get 2 hydroxides. How then could we make our diagram better? Yeah, I could have 2 hydroxide for every 1 calcium. What happened? I wanted green. There we go. Because right now, in order to get the 2 hydroxide that are there, they would have come apart with the 1 calcium. So what happened to the hydroxides for this calcium? We would need to draw a couple more in. So we could draw in a couple more hydroxides. And now we have a lovely saturated solution of calcium hydroxide. Yes? Now, to be perfect about it, we would actually have to also fix our crystal lattice so we have a 2-to-1 ratio of the positive ion to the -1 ions. But it's super hard to draw crystal lattices that are not a 1-to-1 ratio. So we're not even going to try. Does that make sense? Because it's just really hard. Like what would you do? I don't even know how you would do it. You would do like, you would have a calcium, and then you'd be like, okay, and here I have a hydroxide, and here I have a hydroxide, and then I have another I don't know. Like it just becomes really hard. Yes? So we're not even going to worry about it. So that takes care of question number 7. Would anybody like a printout of this? Yes? Okay, file, print. Print. So far I'm printing 1. Anybody else? Ha, I knew it. 1, 2, 3, 4, 5, 6, 7. Okay, I'll do 10 just in case, because I know that some of you will be like, oh, can I have one of those, even though you didn't put it in your hand now. I don't know why. But every time, it's always the same. Oh, I don't want 100. That wouldn't be good. Okay, let's send that to school copiers. There we go. Print. All right. So you have a little bit of time right now to finish up the lab and hand it in. Also, if you're waiting for other people to finish up the lab, you can redo a quiz if you need to. You can take a quiz if you've missed one and need to get caught up on it. You can study for a requiz if you need to. But before the end of class, so maybe at about in about 15 minutes or so, we're going to start on a little bit of unit 2. It won't take that long. We'll actually have more time after that as well, just to get going on things. But I do want to make sure that I teach you this tiny bit of unit 2 before the weekend. Okay? So right now, work on your lab, get it handed in. Take some time, think, do I need to redo a quiz? Do I want to study to redo a quiz? That kind of thing. Hey. And I just wanted to take you through the very first few pages are just reference pages. So if you're in Unit 2 and you've forgotten how the sig fig rules work, there is a sig fig summary page. You don't have to look at all these. You can just be like, oh yeah, there it is. There is a math with sig fig summary because we're going to learn the math with sig figs, okay? There is a common conversion factors. I'm actually going to print one of these out for you separately so you don't have to flip to the front of the book the whole time. But if you lose that separate one, there will be one in your book, okay? We have some conversion tips for metric conversions. So if you're doing metric conversions and you get stuck, you can be like, oh, we have that little, thing there. And also tips for using your calculator. So if you're like, I don't know how to use my calculator to do scientific notation, you can look there. Okay, so that's just like reference material. Then we get into the meat of it, which is where we're going to start today. And we are going to look at rounding numbers, which sounds incredibly easy and mostly is. I think probably, did you learn some of this in elementary school? Yes? Okay. So some of it is just as easy as it was in elementary school. Okay, and then we'll throw in sig figs. All right, so here we are. The rules are just like in elementary school. We look at the number we want to round to. I want to round to the thousands position. So that would be the one that's in the box, that 8 right there. And I look directly to the right, and I see a number, and it is an 8. That belongs in the category 5 to 9, and so I round up to 9,000. This should seem really straightforward. Does it? Yes, excellent. Okay, similarly, if I have a 1 and I look to the right and I see a number that's between 0 and 4, I will round down, or I will, in other words, I'll just keep the number the same. It will stay as a 1. One thing to watch out for, sometimes people get into the trap of double rounding. Okay, they'll look at this and they'll be like, oh, well, the 5, don't write this down. The 5 rounds this one to a 5, and then this one would round to a 3. No. Don't do that. Okay, always look only at the number directly to the right. You can essentially ignore all the rest of the digits. Just look at that one number. That number is a 4. And so we don't round up, we round down, and it stays as a 2. This one's easy. 8 is bigger than 5, so this rounds up to a 4. Now, let's say I said we have 400,400. And what if I said round to 3 sig figs? Okay. What that means is that I want 3 sig figs. Yes? So I look at the number to the right, and it's a 4, so I keep the 0 as a 0. But if I just had 400,000, that would be a problem, yes, because I wanted to round it to 3 sig figs. How many sig figs do I have in this number right here? 1. So you have 2 choices. You can either put the overbar, okay, or what's the other thing that you could do? You could write the number in scientific notation, right, with the decimal. So you could change it into 4.00 times 10 to the, and we moved our decimal place, 1, 2, 3, 4, 5, 10 to the 5. Okay. The other thing that people will tend to do wrong when they read something like round to 3 sig figs, they'll be like, oh, okay, I'm going to round that to, I need the 400, so I'm going to round that to 400. You see the problem there? We have 3 digits. That part's okay. But we took 400,000 and we turned it into 400. That doesn't work, right? You cannot lose a bunch of places in your number, okay? So when it says round to 3 sig figs, that doesn't mean cut off everything after those 3 sig figs. It just means that you want this number to be the last significant figure, and then the rest of them, if there are any more, they will just be zeros. Does that make sense? Okay, you've got practice, just in case it doesn't. These are just reminding you, do not double round. That's where you would round, you know, you would look, so you would say, oh, I've got a 4, and I look at the 9, that rounds that to a 5, and now the 7 looks at the 5 and sees that, and they go, oh, it's an 8, but no, don't do that. And if you think about it, if I have 749, and we've got our number line between 700 and 800, is 749 closer to 700 or is it closer to 800? It's closer to 700. So that should make sense just from a number line perspective, okay? But in other words, do not double round. Only look to that single digit to the right. Don't look past that digit. Okay. Oh, and just to mention it, the choice to round up, when we actually have a 5, when we're right in the middle, the choice to round up is an arbitrary choice. That was chosen at random, yes? And in fact, there is a more complex rounding rule that you might learn in university, but I'm not going to teach it to you now because you don't need it. If anyone is interested in how we randomize up and down for 5s, you can come and talk to me about that later. Okay. This is another example of don't just cut the number off. So if we're like, say, round to 3 sig figs, sometimes people will say, okay, I'm going to round right here. So I'm going to look to the right, and I have to round up. And I made a typo here. Can anyone see my typo? That should be a 4, not a 5, okay? However, sometimes people will draw this line here and they'll be like, oh, I'm going to round here. And so they will simply cut off the number and make it 334. And that would be wrong because it should be 334,000. That might look silly, but you'd be surprised at the number of times I'm like round to 3 sig figs and people are like, look, I did. Right? And they forgot that there was 334,000, just not 334. Okay, happens a lot. The last little note is please use an arrow rather than an equal sign when you are rounding, because it is not correct to write that 749 is equal to 700, because those two are most definitely not actually equal. 749 is not equal to 700. You could write 749 and the arrow would mean rounds to 700. Or you could write 749 is approximately equal to 700 if we round it to 1 sig fig, okay? But you would not want to write 749 is equal to 700. That would be wrong. No. Okay? Do you feel like you need to see another example of the overbar and scientific notation, or do you feel good? Anyone want an extra example? Yes? If you don't want an extra example, you can just start work on the questions. Okay, I'm going to do this one here. So let's take our number. We have 4,900,627, and we want to round it to 2 sig figs. So that means I want 2 sig figs. So I'm going to take a look to the right. That means it's going to round up. So the 49 becomes a 50. But this number only has 1 sig fig. So in order to make it have 2 sig figs, we have 2 options. We can either say this is my last sig fig, that 0 there, that's 2 sig figs. Or we could turn it into scientific notation. We could move our decimal place 3, 4 places. So it would be 5.0. So now we have 2 sig figs because of that decimal times 10 to the 4. Okay. One more. Let's round 83047 to 3 sig figs. Here we are. We want 1, 2, 3 sig figs. Look to the right. That is a 4, so that means the 0 will stay as a 0. But I wanted 3 sig figs, and this number only has 2 sig figs. So I can either say that 0 there in the hundreds position is my last sig fig. That's my uncertain digit. Or I can write 8.30 times 10 to the 1, 2, 3, 4. Okie dokie. Your homework, there's a little bit from Unit 2, only a small amount. Most of it's just study for your test. Okay, so your homework in Unit 2, pages 7 and 8, and also 2.1D, which is pages 18 to 21. It's watching a little video with Tyler DeWitt and doing some practice problems. You love Tyler? Tyler is the best. And then he abandons us in grade 12 and doesn't do anything till the last unit of grade 12. But yeah, so Tyler is going to teach you how to multiply and divide with significant figures. Okay, which also gives you a little review of significant figures, counting them before your test, right? So none of the unit 2 stuff is on your test, okay? Not on the test. Other than that, you're reviewing for your test, okay? I did want to point out on our team that I have, where did it go? Oh, where is it? Teams, and I want upcoming quizzes and tests. That's what I want. So you can see here is our upcoming test. Make it a little bit bigger. And down underneath it says need extra practice. In the general file channel in files, you are going to find a Unit 1 EMAPS folder. It contains all the worksheets. So if you want to redo any worksheet and you want a blank copy, you can go, you can say general. Where's my files? Oh, I don't want to add a tab. Yeah. Sorry. It's like walking through glue. Okay, files. We go to files. And look, here's Unit 1. And if you want to have some extra practice with accuracy and precision, there's the original worksheet, there's the extra practice worksheet, right? We've got practice making measurements, extra practice making measurements, extra practice. making measurements. So all of those, if you filled them in and you want blank copies, they're all here. Yes, you sure can. And the other thing I've also put up is some reference pages in Hubden. So that's the book that you signed out if you were away on the day that we signed out Hebden, which is like the extra workbook. Come and see me, we can get you a copy. And then I attached the extra practice for scientific notation and counting sig figs. And I'll also put up the answer keys for the quizzes here. Sorry, that was a lot of talking. Thank you for indulging me. And now if you have any quizzes that you want to rewrite or you're just working on whatever you're working on, we're good. Okay? Does the test include equipment? You should know quadruple beam balance because we've used those a lot. You should know ruler. Okay. Other than that, I'll put them on as black diamonds. Yes? So equipment is mostly black diamond stuff. What you should know for equipment is you should know which things are good at measuring and which things are not good at measuring. You should know which things are better at measuring than other things that are also good at measuring. So like if you have a totally skinny little pipette, that's going to be better at measuring than a thicker graduated cylinder. Because the skinnier the thing, the higher the volume will change with just a small amount. Yes? How long will the test be? You will be able to easily finish it within the block. And it is, I think, like front, back, and it's like legal form, but there's pictures in there too, right? So it's like, oh, here's a burette or whatever. So some of that is pictures. Yes. Yes, it does include the homogeneous and heterogeneous. Elements, compounds, and mixtures, yes. Yep.